Blank piece of paper, please, and on top of it, if you will, write factors. Factors. The definition of Jan said pair factors is, ladies and gentlemen, what is a factor, John?
Factor is the number in the multiplication problem.
Yeah, things that you multiply together. Now, let's just do this for fun. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'm going to say, write down the factors of exclamation point. Etc., etc., etc. In other words, when you're looking for factors of these numbers, you're just saying to yourself, what numbers could I multiply together to give me that number? Now, the number 1 is a beautiful number because there's only one thing that you can multiply together to get 1, and that is 1. 1 has one and only one factor. What can you multiply together to get 2, Charlie?
1
and 2. 1 times 2 is the only way to get 2. It has, might be how that popped up here. I must have hit it down here somewhere. 1 and 2 has 2. 2 has 2 factors. Another number 3. What times what gives you 3? Sam?
1 and 3.
1 and 3. What times what gives you 4? Now they start getting a little more complicated and a little longer. Please, when you do these, take my word for it, do them down in pairs. You're always going to start with 1 because you can see we've started the pattern with 1. 1 times what is 4? Put the 4 over there. Put them in order from least to greatest. But there's another one there, which is what, Ethan?
4. I mean 2.
2. 2 times 2. You don't have to write it twice, just write it once. 4 has 1, 2, and 4. 5, again, is just 1 and 5. 6, here we go to start some of those things. 1 times 6, put that down, and then 2 times 3. Please put them in order, and please put them down in pairs. I will tell you without a shadow of a doubt that some of you are going to get these wrong because you'll forget, you'll put the 1 down here, but you won't put the 12, or you'll put the 2 down, but you won't put the 6, or you'll put something down there. 7, factors of 7 are just 1 and 7. Factors of 8 are 1 and 8, and 2 and 4. 1, 2, 4, and 8. Factors of 9, 1 times 3. Factors of 10, 1, 10, 2, 5. 11 is a pretty simple one. It's just simply 1 and 11. 12 is 1 and 12. 2 and 6. 3 and 4. 12 has 2, 4, 6 factors. 13 is just 1 and 13. 14 is 1 and 14 and 2 and 7. And 15, wrapping things up, 1, 15, 3, 5. Charlie?
Wouldn't there be a 9 on 9 or 1 times?
Yeah.
Oh, gee, yes. 1 times 9. I broke my own rule there. How about that? Those are factors. Now, the reason why we did factors is because we need a blank piece of paper. This next note thing here is called prime numbers. Prime numbers. prime numbers, ladies and gentlemen, write this down, this is very important, this will come up many, many, many times here. Prime numbers are numbers that have exactly two factors. So if you go back to and look at that list of numbers that we had, and I asked you to circle the ones that are prime numbers. Basically, prime numbers mean you can't divide a number by anything but itself as 1. So these would be the prime numbers. Let's go with a beautiful color. Let's go with a beautiful shade of orange. No, that doesn't stick out there. Let's go purple or peach or lavender, whatever it is. The number 2 is a prime number because it only has 2 factors. The number 3 is prime. 5 is prime. 7 is prime. 11 is prime. And 13 is prime. Okay, those are the first 6 prime numbers. Please note a couple things under prime numbers. Maybe I'll go back to this page over here. It was 2, 3, 5, 7, 11, 13. Please know this in prime numbers that 2 is the only even prime number. Does anybody not know why that is? Why is 2 the only even prime number? Brendan, Nancy, why do you suppose 2 is the only even prime number?
Because it's the smallest and nothing can go into it.
Yeah, but why is it the only, I get that, but why is it the only even one? I mean, what about 6,236? How do I know that's not prime? If you go back and look at our even numbers, maybe it'll come up here. What do you notice about every other even number? Boink, 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 boink.
Every other thing can
Boy.
be divided by 2.
Yeah, every even number can be cut in half, which is divided by 2. So there is always, with any even number, no matter what it is, it could be 732, 2 will be a factor of it, because 2, if you cut this in half, oh boy, which would be what? John, half of 732.
361.
366.
So,
You know that 2 times 366 is going to give you 732. Okay, every even number besides 2, and 2 can be divided by 2, but it gives you that one that you need. So 2 is the only even prime number. The number 1 is not a prime number. Because it has to have 2 factors, and the number 1 only has 1 factor, which is itself. Okay. And also note that just because a number is odd, just because a number is odd, I could spell because, A-U-S, just because a number is odd does not make it prime. There are a lot of odd, not prime numbers. I don't know if you've ever been not prime numbers. A good case in that is the number 15. We had a whole bunch of odd numbers here. 15 is odd, it's not prime. 9 is odd, it's not prime. 21 is odd, it is not prime. Times 7. Dan, did it give us anything else on this? Hold on a second. No. We'll get to those later. There's a question there, Ethan.
is it the same thing with negative numbers? Like,
I don't believe we get into prime and composite with negative numbers. I'll have to look. I don't know is what I'm going to say on that. But I don't think they don't talk about odd prime numbers. I may go back to the confusion and look that up right now. What about odd numbers? Or what about